Hello everyone. In this video, I will be discussing on the arithmetic and logical instructions of 8085 microprocessor. Coming to the objective of this lecture, this lecture will help the students to gain knowledge in 8085 arithmetic and logical. Already we have discussed about this instruction set in the previous video. Once again, I am telling you out of the 246 instructions, there are one category of instruction which are said to be an arithmetic instruction. The other category is on logical instructions. When coming to the arithmetic instructions, there are two possibilities of arithmetic instructions, like addition is there, subtraction is there. When you go for the addition, the results of the addition result is been stored into the accumulator, and whereas as far as the subtraction also, the result of the subtraction is been stored into the accumulator. So to name these instructions, we'll be having a set of instructions like add with a carry. We'll be listing. In addition to that one, supporting to the addition, there is one increment instruction which is separately a category of that one. The other one is a decrement instructions. So starting with this accumulator arithmetic instructions, first is an add instruction, ADD. ADD stands for add register or a memory location you need to point out. So it will add with the accumulator and then store back the result into the accumulator. So when you are going to add two operands, the one of the operands should be kept in a accumulator compulsory. The other may be in a memory location or in a register. Then the result is stored in an accumulator when you go for the addition into the compound. And when you are referring to the memory location every time, it will refer to the HL register pair. Similar to that one, add with carry. Here, A and the specified source register as well as the carry flag would be included, and it would be add and the result is stored in your accumulator. Similarly, add with A immediately with the value given into the instructions. So for example, ADI45H is there. This 45 value is been added with the A register and the result is stored in what? Again in the A register. Similar to this one, ACI is there, which is used to add the immediate value with the accumulator as well as the carry flag. So for overall here, first one is simple add with carry ADC. Next one is A DI add immediate and ACI add immediate with carry. These are the four instructions related to add. And one more, these are all are 8-bit addition operations. When you want to have a 16-bit operation, one more instruction is there, which is named as DAD. So here, one of the register pair would be added with the HL register pair and the result is stored into your HL register pair. So for example, DAD, BA, inhibitor, B and C register pair will be added with HL register pair and the result is stored in your HL register. Similarly, likewise to the add, we are having subtract with borrow, subtract immediate with borrow. So this is first one, SUB is for subtract. It will subtract with A and result is stored in your what? It subtracts A with the register or the memory location and the result is stored in again in the accumulator. Similarly, SUBB, it will subtract with the borrow and the result is stored into the accumulator. And this is one is SUI, subtract immediate value. Here for A minus 45 and the result is stored in your accumulator. SBI, it will take it up, subtract A minus 45 minus the carry flag and the result is stored in your accumulator. And these two instructions, increment and decrement, we will be discussing. These two instructions are very important as far as the programming is considered, because every time we can frequently we go for adding one value to the register pair or one register, that will be done by instructions called as INR increment. What is the register equivalent? INR B. So the B register is added with 1. INR M. The memory content stored at the HL register pair, it will go to there. The value over there will be added with 1 and it will be stored at the specified destination. Now B is the source as well as B is the destination. M is the source as well as M is the destination. Similarly, INX H, INX H, if I give it a HL register pair is added with 1. INX B, if I give it a B and C register pair will be added with 1. Similarly, DCR and DCX. DCR is for registers and DCX is for register pair. Decrement a register pair, decrement a register. DCX is for decrement a register pair by one value and decrement a register by one value is given by DCR. And coming to the shifting into the logical instructions, in your 8085 microprocessor, we are having possibilities of three logical operations and or XOR. In addition to that one, we can go for shifting the bits, rotating the bits, or moving the bits from left to right to left using of rotate instructions. Then we had an compare instructions, complement instruction. Complement is to get the complement of a number. First, we will start with an and our operations and rotate operations and compare. Let's start with an CMP compare instruction. This is one of the most important one. So what it will do is that it will go for comparing a register or a memory location with an active. So here we will specify only a register or a memory location. It will go to memory content and it will go for virtual subtraction with a minus r, any register which is given here, or a minus m, it will do it, and the result is being stored nowhere. Actually, the result is being both the source and destination content is being preserved. Just it will do a virtual subtraction, and according to that one, the flags which are being set and which will be give the information whether A is larger than the specified memory location or the register, A is smaller, or A is equal to 0. For example, A is equal to the register or the memory location if a 0 flag is set. Otherwise, A is less than or greater than. And next one is compare immediate. Even you can go for immediately give a value into the instruction and go for comparison. Like CPI 89. 89 is an immediate value. You can give it up in the instruction and you can go for comparing with the A register value. And logical operations, AND operation is being given by A and A and followed by the register. It does an AND operation between the A and the B register and the result is stored in your A register. Similarly, OR A you will be having OR operation with a register and similarly XOR A would be there, which is about XOR operation with B or any register with the A register or the memory location with the A register, and the result is stored in for all this one. ANA, ORA, XRA, it is the same thing as A accumulator. And next one, you would be having ANI is an immediate value. Whatever the immediate value is there, it goes with the AND operation with this value. 86 is the immediate value. ORI, 86 is the immediate value. It would or with immediate value and the store the results in the A register. XR, X6 would be the immediate value. It is going. Next one is rotate instruction. These instructions are shifting the bits from left to right, right to left. Rotate accumulator left to carry flag. Once the bit is been moved in the carry flag bit is moved to the significant bit. Like that way, this process will be. The bit D0, like LAR is there, RAR is there. So in RAR, bit D0 is placed in the carry flag. The carry flag bit is placed in the most significant bit D0. So it's just like in a musical chair from here, when it goes to the and it rotates, it circulates among that one. So next one is RCL, rotate left. So previously what happens is that each bit of rotated one after the other, one position. So bit 7 is replaced in the D0 as well as in the carry flag. Now, but the carry flag is not shifted into the bit sequence. So RCR and RCL are only to this. Next one, logical instruction, which is nothing but CMA, which is complement accumulator. Getting the negative of a number is called as a C. And if you want to complement a carry, you can go for CMC, and we want to set a carry flag STC. These are the instructions which are related to arithmetic and logical instructions. I hope by this one, we are able to design very wonderful programs on 8085 microprocessor program. Thank you everyone for watching this video. Thank you.